Hello and welcome to another another past paper session. Today's paper is an S2 exam. This is May June 2024, variant 6.2. We will begin solving. The first question is this. Let me just grab my calculator. I have the marking scheme open in front of me. It says a random variable x has a distribution Poisson. This use a suitable approximating distribution to calculate probability of x less than or equals to 150. So since lambda is greater than 15, so I'm going to use a normal approximation. So probability of x less than or less than 150.5 rounds off to this. Okay, lambda is 145, so mean is 145 and variance is also 145. Z less than 150.5 minus 145 divided by. Okay, 150.5 minus 145 divided by root of 145 gives me 0.457. Pi of 0.457. Check what's 5.457. I think I should erase some of these things now so that I can clearly 0.457. Six seven three six six seven 4 1 6 7 6 1 6 7 6 1. Okay, 0.676 rounds off to 0.676. Okay, justify the use of your approximation. So lambda is greater than 15 is the justification of this approximation. Yeah, 145 is greater than 15. Often, you have to make sure that you're stating the lambda, which is what is written here, that it's explicitly required that you mention 145. If I just write lambda is greater than 15, for although I've stated lambda equals to 145 here, so that works, but even then you should be clear because justifying is using evidence to prove. Okay, Henry wants to use a random number sample from the 804 students in his college. He numbers the students from 1 to 804 and then uses random numbers generated by his calculator. The first 20 random digits produced by his calculator are as follows. Henry's first two students' numbers are 567 and 109. Okay, use Henry's digits to find the numbers of the next two students in the sample. So 843 won't hold. 843 is not possible. The next number has to be 109. 109 is also repeated. The next number is 665. And then 021 or 21 are the next two numbers. Okay, let's check if justification was required. So P1 for each allows if the answer is given, count press 2 and end. Okay. So I should write explicitly why I'm disallowing them. One is repeated, 843 is not possible, and so on. There were 30 students in Henry's sample. He asked each of them how much time X hours they spent on social media each week on average. He summarized the results as follows. Uses information to calculate an unbiased estimate of the mean and variance. Chosen to calculate an unbiased estimate of the mean and show that an unbiased estimate of the variance is less than 0.1. Okay, so is 610 divided by 30. 20.33. For the variance, you do n over n minus 1. The sum of x squared divided by n minus the mean square. I'm going to use the exact version of the mean and say that this is 61 over 3. 5 over 87, which rounds off to 0.057475, which is less than 0.1. Okay, that's shown. Yeah, shown. Let's move on to the next question. Henry's friend claims that Henry has probably made a mistake in his calculations of sum of x or sum of x squared. Use the answer part B to comment on this claim. Use your answer to part B to comment on this claim. The variance looks very small, which means that there was probably an error in calculating 20 hours a week is reasonable, but the variance being 0.0575 to the variance is very small. So there is probably an error in sum of x squared. I'm not absolutely sure about this answer. Let's check from the markings. It's very small, so Henry has made a mistake. Claim is probably correct. Yeah. Okay. A student wishes to estimate the proportion P of students at a college who have exactly one brother. She surveys a random sample of 50 students at a college and finds that 18 of them have exactly one brother. This is the test statistic. She calculates an approximate alpha percent. No, not the test statistic. Okay, she calculates an estimate of the alpha percent confidence interval for P and finds that the lower limit of the confidence interval is 0.244. Correct to 3 significant figures. Find alpha correct to the nearest integer. Now, for the lower limit, the formula for the population proportion is basically PS minus Z value into PS QS over N. Okay, that is the lower limit of the population confidence. The PS is 18 out of 50. Can I take them in decimals? I think that would be easier if I took it in decimals. It's 0.36. Okay, so 0.36. I don't know the Z value because I don't know the confidence interval, but this comes out to be 0.36, 0.64, and divided by 50 goes to 0.244. Okay, so 0.36 minus 0.244 divided by 0.36 into 0.64. So the Z value is coming out to be 1.709. Now, when I have Z value as 1.709, what I can then say is that I can calculate the confidence interval. 1.709 translates to how much percent? Let's look at that. 1.709, 1.70 and 8 at the end. 9562.9562. So 0.9562. That means that what am I left with at the other end is 0.0438. So that 0.438 should also be here. So 1 minus 2 times 0.0438 is 0.9124. So 91.24. Find alpha correct to the nearest integer. So 91% is the confidence. Check if that is correct. Yes, that is indeed correct. Another question out of the way. Question number 4. A random variable x has a distribution this. Two independent values of x denoted by x1 and x2 are chosen at random. Write down the value of probability of x1 is greater than x2. Okay, so if I move this to this side, becomes z is greater than 0. Oh, sorry, difference is greater than 0. Okay, the probability should probably just be zero point 0.5, I think, because the mean is going to be 0 and the variance is going to be 12 plus 12, which is 24. Okay, so whenever I convert this to this, it's going to give me probability of z greater than 0. That's 1 minus phi of 0, and 1 minus phi of 0 is 0.5, so 0.5. Again, that is what I predicted, because if you're just comparing two simple values together, the mean is definitely going to be 0. Okay, since there's no multiplication or any other thing else happening. Since it says write down, this is more of a interpretation question, so you don't need to show me all the working, although you can do the working on the side, erase it later, do it on a blank page, wherever you want, and that should also work. Okay, since it says just write down, you don't even need to offer me an explanation. Then it says probability of x1. I'm going to bring this to this side and say that this is greater than minus 3. So the difference has an expression that says x1 minus 2 times x2. The mean is going to be 10 minus 2 times 10, which is minus 10. And the variance is going to be 12 plus 2 square times 12. 48 plus 12 is 60. This is going to become z is greater than minus 3 minus minus 10 divided by root of 60. 7 over root 60. 0.9037, 904. Eight one six one. 1831. Okay, let's check if that is the correct answer. Yes, that is the correct answer. I always forget to round off to 3 decimal places. That is what I should do at the end of every question. Okay, 5. The number of goals scored by a sports team in the first half of any match has the distribution this. The number of goals scored by the second in the same half has this. You may assume that the distributions x and y are independent. The probability of x less than 4 is just the probability of 0, 1, 2, and 3. So e power minus lambda plus lambda e power minus lambda. Now you have to write all of this on the exam as well, regardless of whether you're using your calculator to do the calculations or not. Okay, so I am then going to use my calculator directly from the distribution and say that Poisson CD variable b 1.625. Check. Yeah, that is the correct answer. Find the probability that in an and the team scores at least 5 goals. So this has to be together in the first half and second half. So that's going to be 5.5. The total will have 5.5 as lambda. At least 5 goals means greater than or equals to 5. That means 5, 6, 7, and so on up till infinity. But I can't do that. So 1 minus probability of 0, 1, 2, 3, and 4. Okay, again, I should write all of that. 1 minus e power minus lambda into minus e power minus lambda minus. Okay, so you get the point. I'm not doing the writing part completely. I'm just going to put it on my calculator and calculate. 4, 5.5, execute. 1 minus 0.3575. 0.6425. Using 64248. So that rounds off to 0.642. I've used the exact value. Yeah, 642. 643 is also correct. Part C, given that the team scores total of 5 goals in a randomly chosen match, find the probability that they score exactly 3 goals in the first half. Okay, given that. So conditional. What is the condition? That should come up in the denominator. A total of 5 goals. Okay, a total of 5 goals will mean e power minus 5.5 into 5.5 power 5 divided by 5 factorial. Find the probability that they score exactly 3 goals in the first half. Okay, so if they score exactly 3 goals in the first half, that means that they score 3 goals in the first half and 2 goals in the second half, then get the match gets completed. So 3 goals in the first half means 3.1 and 2.4. So e power 3.1 into 3.1 power 3 over 3 factorial, e power minus 2.4 into 2.4 square over 2 factorial. That should be the case. Let's put everything on the calculator, and it's going to be a tough calculation, so do it peacefully, don't rush through it. You will probably make mistakes. Point 34095, rounding off to three significant figures gives me 0.341. Okay, then 6. The masses of cereal boxes filled by a certain machine have mean 510 grams. An adjustment is made to the machine, and an inspector wishes to test whether the mean mass of cereal boxes filled by the machine has decreased. Okay, so mean is 510. I want to test that the mean has decreased. After the adjustment made, he chooses 120 and X bar is found to be 508. Assume that the standard deviation is 10. Tested the 2.5% filled by the machine has decreased. So this is H0, this is H1. I will draw my critical region at 2.5% on the left hand side. The 2.5% gives me 97.5. 97.5 is 1.960, so minus 1.960. Then the z value of the test statistic. Okay, 508 minus 510. 10 over root 120. That gives me minus 2.191. So inside the critical region, reject H naught, reject H naught. There is evidence that mean has decreased. Okay. Then later the inspector carries out a similar test at the 2.5 certain level using the same hypothesis of another 20 randomly chosen cereal box. Given that the mean mass is now actually 6 grams, find the probability of a type 2 error. So the probability of a type 2 error is the probability of acceptance region using nu mu. Now the problem with the previous part is that I don't have the rejection region. I will have to convert it into a rejection region. For the rejection region, what I'm going to do is I'm going to say that H naught is rejected when Z is less than 1.960. Okay, what is Z? It's X bar minus mu. Mu was 510 over 10 over root of 120. That is the rejection region. Let's first find that out, and then we will be able to convert it into the acceptance region. 511.789. So the probability of acceptance is then region is then x bar is greater than 511.789. Probability of x bar greater than 511.789 is z. Now I'm going to use the new mu. What is the new mu? It's 506. Rest of the things remain the same. I'm going to use the exact values from the calculator. I think I've made an error somewhere. Let's check if I'm making a mistake somewhere. I'm not absolutely sure. Yeah, I'm making a mistake here. Okay, this was supposed to be a minus. Just messing up my calculations. Because the rejection region is to the left hand side, 510. So I get 508.2. I was getting a z value that was like 6.34. I know z values can't be greater than 3 because that's where the limitation on the calculator is, or the table is, sorry. Yeah, I should be fine now. 2.422. 0.9922. 0078. I'm not absolutely sure about this answer, but yes, that's the correct answer. Okay, last question on this exam is continuous random variable. I'm assuming it's going to be a little challenging given that it has a bit of trigonometry in it. So k has to be proven. So you integrate from 0 to pi and say that it is equals to 1. K comes outside. 1 plus cos x equals to 1. So x plus cos x is sine x. K is outside. 0 to pi equals to 1. So pi plus sine pi is 0. Minus 0 plus sine 0 is also 0. So pi plus 0 minus 0 minus 0 equals 1. So k outside, k is 1 over pi. Verify that the median lies between 0.83 and 0.84. Okay, now this is only verify. Okay. So what I'm going to do is I'm going to integrate from 0 to m, and this should be equals to 0.5. Now x plus sine x 0.5 into pi. Now I need to show you when I plug in m plus sine m plus 0 plus sine 0 minus 0 plus sine 0. It doesn't matter really though, 0.5 pi. Now this is from numerical solutions to equation that I'm going to do for you. I'm going to say that this equation has a root between 0.83 and 0.84. That is where this question is coming from. This is my function. What I'm going to do is I'm going to once plug in 0.83 and 0.84, and then it will tell you that there's a change in sign. Okay, it goes from positive to negative or negative to positive, whatever the case may be. Okay, so 0.83 plus sine of 0.83 minus 0.5 pi. That gives me minus 0.0286. And when I do 0.84, gives me 0.0138. Change of sign indicates that m is between 0.83 and 0.84. I think that should be the solution for this one. I'm not absolutely sure, so I'm just going to check. Okay, that's where my solution is. You can see. Okay, so all of these things would work. A change of sign would indicate root, and that's what I've done. Okay, find the exact value of e of x. So x 1 plus cos x from 0 to pi. That should be a tough question. Why? Because it's going to involve integration by parts. Okay, so I've expanded. This becomes x squared over 2, and for that I introduce integration by parts. I write my I late. There's an algebra, there's a trigonometry. Then I have VU minus VU dash. VU is x squared x sine x minus u dash is 1. U dash is 1, my bad. I've integrated was u dash v u dash. So x sine x, and again integrating cos x gives me sine x. This should be sine x. Messing up things because I'm rushing through the question. So pi squared over 2 plus pi sine pi plus cos pi minus 0 plus 0 sine 0 plus cos of 0. Cos of 0 is 1, so that's what I need to be careful about. Pi squared over 2 plus 0 plus minus 1, so minus 1. And that's going to be another minus 1. That's pi squared over 2 minus 2. Is that what I'm looking for? That's pi over 2, not pi squared over 2. Oh, I missed out on the k. There's a k outside. All of this has 1 over pi next. Yep, I think that's the correct answer then. Yeah. So lots of mistakes in this one. That was the last question on the exam. I would ideally want to check it with a calculator as well. It's going to be a calculator where I integrate using a calculator and then come up with. Thank you for watching. I'll be back with another video.
Welcome to Edge Learning, where we are changing dreams into success stories. Let's go. At Edge Learning, we offer courses to help you excel. Whether you're preparing for the SAT, aiming for IBA and LUMS, need O and Olevel tuition, or IELTS coaching, we have the right program for you. Forget about boundaries. We offer learning anywhere, anytime. Our expert tutors provide personalized attention in various batch sizes and one-on-one sessions, along with pre-exam review workshops to ensure you perform your best on test day. Join us at Edge Learning and take the first step towards turning your dreams into reality. So what are you waiting for? Register now or call us.